Good morning, everyone, or afternoon. It's probably afternoon for you. In this lesson today, we're going to explore a kind of story problem, word problem that a lot of people struggled with on our last test. Since these are problems that are going to come up again, and I really also want you to have a strategy for how to think about them, we're going to try that problem again. So this might sound kind of tricky, but I'm actually not going to tell you the problem yet. We're going to work through a strategy first, and then we're going to apply that strategy, a simpler form of the problem, to a more complex problem. So what's going to happen is you're going to be stopping the video every once in a while to do the work. The work is going to be handed in, so you need to make sure that you do it. You can stop the video at this point and gather the materials that you need. You're going to need graph paper. If you forgot to get graph paper or forgot to bring it home or don't have graph paper, don't worry. This could just as easily be done on regular lined paper. So just get paper. It'll be easier for you if you have graph paper, so get that if you have it. You're just going to need a pencil. You could get colored pencils if you want to, but that's up to you. So you're going to just pause the video, go get what you need, pencil and graph paper, and then start back up when you're ready. Okay, so what you're going to do is you're going to be making 3 rectangles, and they're going to be 1 by 10, 1 by 15, and 1 by 20. So I'll do the first one, although you know what I mean. So you're welcome to go ahead and stop and do that. It's a little bit difficult to draw straight lines in this program, so but I'm not concerned about that for the problem. So draw yours as straight as you can, but it's not necessary to spend a lot of time on that. All right, so the question that I have for you is, imagine that these are pieces of wood. So you've got these scraps of wood, basically, and they are so you've got this one that's 10 inches long, and you've got one that's 15 inches long, and you've got one that's 20 inches long. And you've got a project to do, and you need to have all of the pieces of wood the same length. And you want to make sure that you use the wood as resourcefully, as sparingly as possible. So the question is, if I had to cut all of these pieces of wood into the same, or each of these pieces of wood into the same length as the other pieces of wood, what is the largest size that I could make each cut? So in other words, how can I cut these so that they all are in equal sized pieces? And I don't have any leftovers. And the first question is, well, is it possible to do that? So think about that for a minute and go ahead and see what you can come up with. So stop the video and see if you can cut them so that you have no leftovers. But for each piece of wood, that every piece of wood, when you are finished cutting it, is the same size as every other piece of wood. So hopefully what you saw is that if you think about these numbers and you think in terms of least common multiples, so we're going back to that idea of LC. Actually, we're going to think in a GCF. This is going to be a greatest common factor problem. I need to find a number that divides evenly into 10, divides evenly into 15, and divides evenly into 20. If you already figured this out, you figured out that it was going to be 5. So we're going to go ahead and cut them 1, 2, 3, 4, 5 here. And that's going to give me 2 pieces. If you didn't already label them on your paper, please do that. It's one of the things that students often resist, is just showing their work showing showing the thinking behind the work. And it's much easier to do than you guys sometimes realize. So I'm just going to show that I cut that one in 2 pieces. Obviously, my next one's going to be 3. 15 divided by 5 is 3. And I'm making 5-inch lengths. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It leaves me 1, 2, 3, 4, 5. So because that was a 15-inch piece of wood, I was able to get 3 pieces out of that one, each 5 inches in length. I'm going to get 5, 10, 15, and that makes my 20 inches. I'm going to end up with 4 pieces of wood here. All right. So the rest of the question is, how many total pieces of wood of all the same length am I able to get out of these 3 pieces of scrap wood? And another question is, how would I show my work? I've done that a little bit. I've shown a drawing. I'm also going to add something that makes this more clear, so that if I were going to communicate this to someone, I'm saying that this is 5 inches. Okay, so each piece of wood that I've cut is 5 inches. So a way to show my thinking is I found the GCF of 10, 15, and 20. You can stop and write that on your paper because that's what you've done. And that equals 5. Okay. So that allows me to get 2 pieces, 3 pieces, and 4 pieces out of the wood for a total of 9 pieces. So it's really a pretty simple problem. All right, we're going to go to a more complex problem, and you won't have to draw this one. It would be pretty challenging to draw it. So we're going to do it using the same concept that we did just now. Okay, so here's the problem from the test that people struggled with. It's the streamer problem. And a few of you got it partially right, but it seemed like I think only one person, I don't think anybody got the whole thing correct. So we're going to redo this problem, even if you got it mostly right. So Benito is cutting streamers from crepe paper for a party. He has a red roll of crepe paper, 144 inches long. He has a white roll, 192 inches long, and he has a blue roll, 360 inches long. Okay, I'm going to relate that back to the piece of wood problem because it's really the same problem. So imagine now that these pieces of wood are party streamers. But instead of being 10 inches, 15 inches, and 20 inches long, they are now the numbers that Benito has for his streamer, which are 144, 192, and a blue roll 160 or 360 inches long. So you could really imagine stretching out some crepe paper in those lengths, then lining them up much like we did here. Okay, so that's the crepe paper. All right, so what did we do to find the answer to the scrap of wood problem? Well, we found the GCF of our long pieces of wood. We're going to do the same thing here. You're going to find the GCF of 144, 192, and 360. Okay, just in case you've forgotten how to do that. Yep, it's a birthday cake problem. So your job is, it's not the only way to find the GCF, but it is, as we found in the last chapter, a really easy way to do it for large numbers. Now, when you have 3 numbers and you have GCF, it's okay to put all 3 numbers in the birthday cake. With LCM, you would have to find the LCM of 2 of them and then find that number with the 3rd number and find the LCM of that. So that's where sometimes it gets confusing. In this case, with GCF, we're trying to find common factors. So we want to go ahead and put all 3 numbers in the birthday cake. All right, I'm going to give you the first one. We'll work through that together, and then you're on your own to finish this problem, and you will be bringing it into class, and we'll see how you did. finding the GCF is only step one in the problem. So I'll go through that with you in just a minute. And we'll look back at the problem in just a minute. All right, so if I'm going to find the GCF here, I'm going to start with 2, just as an easy prime number to start with. 2 goes into 14, 7. 2 goes into 4, 2. So it's that upside down division, works really easily. 2 goes into 19, 9 with a remainder of 1. I'm going to put my remainder there like short division. 2 goes into 12, 6. All right, 2 goes into 36, 18, and I have a 0 on the end. It's clear that I'm not done here. It's clear that there is at least one more step in the cake, and probably more than that. All right, you need to stop the video, write down the problem. You're going to find the GCF of those party streamers, 144, 192, and 360. When you find that GCF, what is that going to tell you? What is the GCF going to tell you? Well, just like in the scrapwood problem, it's going to tell you how you can cut the streamers so that you have all the same length streamers in the end. We're going to use this to figure out how long the cuts are going to be, or how long each piece of streamer will be after you cut it. So find your GCF, and then come back to the video, and we're going to look at one more thing. Okay, so problem 4, if he wants to have all colors of streamers the same length, just like our pieces of wood, what is the longest length that he can cut? So what that's saying is, if he takes the 144-inch long crepe paper, and he cuts it up into pieces, and he takes the 192 and cuts it into pieces, and he takes the blue roll 360 and cuts it into pieces. He wants all of the pieces to be the same length. Every new piece that is cut, he could lay them on top of each other, and they would all fit on top of each other. So the GCF will tell you what size they can be cut into, but that's only half of the problem. The next half, problem 5, says if he cuts that longest possible length, that meant find your GCF and figure out what he's going to cut them into, how many streamers can he cut? Well, that is exactly like this problem right here, where once they were cut, we figured out how many pieces would be in each one. Once we know how many pieces were in each one, what did we do? We added them up. And so our final solution was, after we'd cut up the pieces and figured out how many each one would make, each piece of wood would make, we added those little pieces together to get the answer to the problem, which was how many pieces could we cut all together. It's exact same idea here. Cut the longest possible length, how many streamers can he cut? All right, so your job is find the GCF. Once you've found the GCF, you're going to need to divide each one of these numbers. 144 is going to need to be divided by the GCF, so you know how many streamers came out of the 144. The 192, you're going to have to divide that by that same GCF to figure out how many streamers he was able to get out of the 192. And 360, you're going to need to divide that by the GCF in order to figure out how many streamers he was able to get out of that piece of long streamer. Once you have that, we want to know how many streamers can be cut all together. All right, that's your job. You're going to finish the problem. You're going to make sure that when you turn this in, it should have this picture. It should have the completed birthday cake, and then it should show how many streamers were cut from each long streamer, how many short streamers were cut from each long streamer, and then it should show the addition of all the streamers together. All right, that's the complete problem. I look forward to seeing your results when we are back to school. Have fun.